In this video series, we're going to look at how to add and subtract rational expressions. In order to do that, we need to remember how do we just add regular old fractions. Let's say we have 4/5 plus 7/8. How do we add regular old numerical fractions? You need to have a common denominator. Now, the common denominator here is, well, what is the least common multiple of 5 and 8? And you would say, well, that's 40. And so what happens is you multiply the top and the bottom by a factor that gets you the 40. And so I'd multiply the bottom by 8 and the top by 8 here. Same thing. I look at the next fraction. I have an 8 in the bottom. I want it to become 40. So what factor is missing to get that? And that'd be a 5. So I multiply the top and the bottom by 5. And then when you have your common denominator, which was 40, we have 32 over 40 plus 35 over 40. That's going to give us 67 over 40 for our answer. So when you're adding numerically, you find a common denominator. The same thing works with rational expressions. You need to find a common denominator. And what I did was I looked for the least common multiple, the LCM of the denominator, and that's what we do for our rational expressions. So first thing you want to do is you want to identify what is my common denominator going to be. They do not have the same denominator here, so I need to look at what is the common one going to be. What's the least common multiple of 3 and 6? Well, that's 6. The least common multiple of m and m squared is m squared. So I want my denominator to be this, and this is the key. This is the most important step. You make sure you write this down. You want the denominator to be this. However, right now, it's just 7 over 3m for the first fraction. The second fraction, it's 5 over 6m squared. So I want my denominator to be this. Right now I have a 3m over here. So what do I need to multiply by to create 6m squared? Well, I need to multiply the 3 by 2 to create the 6. I need to multiply the m by m to create the m squared. And so I multiply the top by the same thing. I want my denominator to be this. And right now it's 6m squared. That's what I want it to be. So I don't have to do anything to this other fraction. I can just leave it alone. And so let's simplify. 7 times 2m is going to be 14m. We created our common denominator of 6m squared. And now I have 5 over 6m squared on the right. So since we have the same denominator, just like we have here at this step, we can actually add across the top. It's just here when we add across the top, 14m and 5 are not like terms. So I cannot combine them. So I just write down 14m plus 5 over 6m squared. And that is my simplified rational expression by adding the two together. So the key concept that we have to remember is when you are adding or subtracting rational expressions, we need to find a common denominator. And you want to make sure you write it down because that shows you what you want both denominators to look like. And so let's try a subtraction problem. I'm going to give myself some room to write down my common denominator. I have 2 over 3y squared minus 1 over 12y cubed. Again, the first thing I'm going to do is I'm going to identify what's my common denominator by looking for my least common multiple of them. So I look at my coefficients. I have 3 and 12. The least common multiple of 3 and 12 is 12. I have a y squared and a y cubed. That least common multiple is a y cubed. So this is what I want in the denominator. But right now, I have a 2 over 3y squared. But I want 12y cubed. So I look at what am I missing? Well, to get the 3 to become a 12, I multiply by 4. To get the y squared to become a y cubed, I multiply by y. And so I'm missing that in the top and the bottom. That's what I'm going to multiply by. Look at my next fraction. I have 1 over 12y cubed. I want the denominator of 12y cubed. That's my common denominator, and that's what I have. So I'm not going to do anything to this second fraction. And so let's just simplify. 2 times 4y is 8y. 3y squared and 4y is my 12y cubed, my common denominator. And I have 1 over 12y cubed. So now that I have the same denominator, I can add or subtract. It's just 8y and 1 are not like terms, so to do the subtraction, I just write down 8y minus 1 over 12y cubed. And that is my simplified rational expression after doing subtraction. And so the key here is finding your common denominator. Now, I just went through and told you it's the idea of least common multiple of it. And the way you figure out the least common multiple is I would look at maybe even the prime factors of 3m is 3 and m. The prime factors of 6m squared is 2 times 3 times m times m. And what I look for is, what do they have in common? They have a 3 in common. They have an m in common. So I write that down. That's what they have in common. What are they missing? Well, they're missing the 2 and the m. And so 3m times 2m is 6m squared. And so this is how you kind of find your least common multiple. 3y squared is really a 3 times a y times a y. 12y cubed is really a 2 times a 2 times a 3, and then 3y's. And I look at what do they have in common. They have a 3 in common and 2y's in common. So I write that down. 3 and 2y's is 3y squared. What are they missing? Well, they're missing the 2 and the 2, which is a 4, and the other y. 3y squared times 4y is 12y cubed. So if you need to show your work for finding the least common multiple, this is what you do. You look at the factorization of your terms, look at what they have in common, and then look at what remains when that's crossed out. Look what they have in common and look what remains when that's crossed out. So let's look at example 3. It's a little bit different. We have 4a over mn plus 2a over np. The first thing I'm going to do is I'm going to identify what is my common denominator. And I'll go ahead and use the process that I showed at the end of the previous two examples. The prime factorization of mn is just mn. Of np is just np. So what do they have in common? They have an n in common. So I write that down. Well, what remains? The m remains and the p remains. And so my common denominator is m n p. This is what I want in the denominator for both fractions. So right now in the first one, I have 4a over mn. Well, I want mnp. Also, I'm missing the p. So I am going to multiply the bottom by my p and multiply the top by the p. Same thing with the next fraction. You have 2a over np. Well, what are you missing? I want m np. So I'm missing the m. So I'm going to put one in the bottom. I'm going to put one in the top. And then I'm going to simplify from there. Well, I have 4ap over mnp plus I have 2am over mnp, because remember, variables go in alphabetical order. So to simplify from here, I would just add the tops together. They're not like terms, so I can't combine them. So I'm just going to write down 4ap plus 2am over mnp. Now what's new about this one is when I'm done, I take a look at what my numerator says. I can see right now there is a GCF in the numerator. The GCF of the numbers is a 2. The GCF of the variables is an a. So I can factor out a 2a and get 2p plus m over m n p. And that is the completely simplified rational expression. So even after you do the addition or subtraction, do take a look at your numerator and make sure to check, can it be simplified? Can it be factored? So let's look at one more example in this video. We have x over x plus 3 plus 3 over x minus 4. I need to find my common denominator. Now these are actually easy, and there's a reason why I put parentheses around these in this example, is it allows you to see the common denominator very easily. You cannot look at the x as an x. You have to look at the object. The entire object is x plus 3. The entire object is x minus 4. So in finding the common denominator, that is the factors. This factor is x plus 3. The other factor is x minus 4. You can't break them down any further. So what do they have in common? Well, nothing. You can't say they have an x in common because that x is part of the factor. So they have nothing in common. So you write down what remains. Well, what remains is the x plus 3 and the x minus 4. So that is your common denominator. That is what I want. And so on the first fraction, I have an x over x plus 3. I want x plus 3 times x minus 4. So what am I missing? I'm missing an x minus 4 in the top and an x minus 4 in the bottom. In the second fraction, I have 3 over x minus 4. So what am I missing? I'm missing the x plus 3. So I'm going to put that in the top. I'm going to put that in the bottom. And now I'm going to simplify and add the two fractions since they have a common denominator. So to simplify, what I'm going to do is distribute across the top. And that's going to give me x squared minus 4x over my x plus 3, x minus 4. When I distribute in the other fraction, the 3 goes to the x and to the 3, and that gives me 3x plus 9. And so now I simplify. X squared minus 4x plus 3x plus 9 is x squared minus x plus 9 over the x plus 3, x minus 4. And I check, can x squared minus x plus 9 be simplified? Do numbers multiply to give you 9 and add to give you negative 1? No, it cannot be factored. And so that is my final answer. And so yes, adding and subtracting rational expressions are hard. They're difficult. You have to remember this idea of common denominator to go through. And the key to it is if you can find the common denominator, you write it down. That allows you to see visually what you want the top and bottoms to look like. I'm missing my x minus 4, so I have to put it in the top and the bottom. I'm missing the x plus 3. And so that, in my mind, is the key. If you do not write down what the common denominator is, you may miss one of the factors you're supposed to put into the fraction before you add and subtract to simplify.